Hello, I'm Taryn from Driver Assist Tech, the organiser and marketing partner for today's session. Thank you for joining us today for this motion data hosted webinar on this exciting topic, revolutionising front crash prevention testing with the MD-TR-TR. The information presented in this webinar will be available after the session, but if you'd like further details, please get in touch with us. And now over to Ed.
Hi, everybody. Just a little bit of housekeeping before we get started. So the webinar is being recorded. You currently are muted, and we'll open that later for discussion time. Please feel free to use the chat functionality and the Q&A, and we'll be able to go through those at the end of the presentation. So thanks again for joining, and now off to Steve and Paul.
Good afternoon. I'm Steve. I'm the Manager Director of Motion Data.
Paul Brett, a Technical Manager of Motion Data.
So we're here today to talk about our truck trailer target, the MD-TR-TR. The MD-TR-TR was designed for the IIHS front crash prevention test. We looked at IIHS, and they were doing full collision warning system notifications by driving at a real truck trailer, a dry vanguard trailer, a very common trailer in America, and recording when the front forward collision warning was activated. If it activated, they were swerving around the vehicle. If it did at a certain point in time, if it didn't activate by that point in time, it was deemed a fail. So we talked to IIHS about designing a target and what they would want from it. And one of the realistic things they wanted from it was overhang, the correct size, the correct image. So as you can imagine, trying to make a 4 metre high, 13 odd feet, 9 feet wide target has certain challenges. So we thought of different aspects of how to do this. One of the early designs we came up with a simple slab element, because obviously if we're going to impact a target such as this, is what happens after that impact? How do we put it back up? So we almost had it, as you can see on this idea, a rolling section at the back. We could roll it back up like a weeble back onto its feet. If it hit, it was going to have a cushion possibly behind it. And you can see in this second image there, it would be mounted on a skid box. It would slide a little bit as well. But one of the issues with this was it wouldn't have a correct radar signature because it didn't have any overhang where the underride protection goes on. And when we analysed a lot of the trucks, that's where the major radar signature came from the wheels, the axles, and the bed of the truck. So this type of design was quickly thought not suitable. So then we started to think of along the lines of the Softcar 360, many pieces. But one issue with the Softcar 360 is obviously it is in many pieces. And then when you've got a 4 metre high section, how do you get the last few pieces back on top? So how do you reassemble it once hit without having ladders, cranes, forklifts, etc.? So then we started to think, well, what about if we use an inflatable? The inflatable section at the top is generally just by the shape. Most of the signature came down from low down in the object, the bed, the rear doors, and the axles. So the bulk of it didn't really have a radar signature and wasn't really necessary. You thought, hey, why not have it that upper volume, which is just there for the camera, inflatable? So then how do we put an inflatable on the ground? How do we make it the right size, the right shape, and robust and stand up, and also allow it to hit? So then I thought, well, if we bring some foam elements into it, we can use the foam to attach it to a base. We can then get a better signature and control our signature more easily. So obviously we started off trying to make it roughly effectively the same size as the drive van trailer. So the rear end, rear axle. We also found that the space between the axle was important to help with the signature as well. The radar signature often bounces through, it hits the bed and gets different detections along the length. It gives it a 3D element of a real truck rather than a flat slab at the front. So the gap between the wheels, the axles, and all that sort were inherent in its requirements for a radar signature. So then we took the inflatable section. Well, when you build an inflatable, you've got to stop it bulging out like a big balloon. So you obviously have sewn in elements within that, and that stops that ballooning effect. The more stitches and elements you have crosswise, the flatter it gets, the less ripples you have. But you can cover that by putting on a layer. And as you can see here, when we put the rear image on the back, we get rid of that shape and have a nice flat image. We can also then do the same with the sides, skin the sides, and then apply that. So therefore it gets rid of that element of the curvature and the stitching on the side. We then add the wheels through an imagery as well and make that skin the wheels, and then it looks more and more like a real truck. Then we have to think, well, how are we going to keep it down on a test track? Because people don't like drilling holes in test tracks and making it heavy and tying it down. And plus the fact we want to be able to hit it. So we had the next concept was then we sort of add a nylon base, which would act as a weight, and also it'd be low friction and allow the object to slide along. So we put the base under the pedestal, what we call the 4 pedestals, which is mounted to that by poles, vertical poles with foam over the top, which sandwich between the pedestals. And the inflatable itself is attached to the base with what we call a keeder rail, which is like a figure of 8 C-shaped rail with a bead. It runs through it from the inflatable to the nylon. So now we have it all in one. The nylon and the target is now attached on the weight. The base is now heavy enough to hold it down and to act as a skid plate when it moves along. We've also overhang at the front, so we can add extra weight for if needed. And obviously the shape of it, we try to reduce the wind load. So the target we've chosen to manufacture it is by what we call a cold air method. It's a constant feed from a blower, where it constant feeds the air into it to inflate it. And the reason we went down this is because obviously to make a sealed airtight target such a size as this would be a very, very expensive idea indeed, and it would probably be cost way too much to be usable. And also, if you do damage it and the air leaks, it also becomes unusable. But in this instance, as long as you put more air in than you're taking out, it'll stay inflated. So you can have the option to repair it if it gets a small hole in a tear. It will often be inflated with just a bit of duct tape or things like that to keep the air inside it. So it's not imperative that it's completely sealed. So, but we looked at that tube and thought, is that going to be an issue with the radar and with the camera? So the tube that we have on the target is detachable on impact. It's attached to the target with Velcro. So as the target is impacted, it breaks away as it slides off, so it doesn't drag the power source or the inflatable blower with it. The tube is a light grey to match the tarmac, so the cameras don't see it as freely as they should, as they could. It's round, radii is round, so the radar signature is not very high on it. And also it's at an oblique angle from the target, so any radar signature should bounce off it. So it shouldn't really be detected that much. And it's right at the back of the target, and it can be put on the left side or the right side, depending which way you're going to drive around the target. So putting all those things together, this is what we ended up with. So we ended up with a 4 meter high, 6 meter long TRTR trailer, which sits on the nylon base And when a signal in the lane, it resembles the correct sizes for a trailer, a dry vanguard trailer, including the underride protection, which is foam, which is velcroed on, it detaches on impact, it gives it that reflection and that idea. Since it's photographed, we've added the lights and the number plate. This is the first prototype, and it sits, as you can see, on its own merit on the test track quite cleanly. And so now we've solved the problem of the image. It looks like the idea it's supposed to be, the object it's supposed to be. For the camera and the infrared materials are the same type of readings, and the LiDAR pleats and all that have the same ability to reflect, just like any other real truck. So as motion data are part of the ISO Committee Working Group 16 of targets, there's a certain methodology that you can apply to targets that we've done from the 19206-1 right up to the new ones that are coming through: bicycles, cars, pedestrians, motorbikes, animals, and things that we're working on. So we've applied that methodology of defining a target in the ISO to this trailer. So it has the same plots for radar, camera, LiDAR, and outright infrared reflection. And we have all that data available. And I'm going to pass you over now to Paul, who can explain the most complex part of that, and that's the radar aspect of it.
Yes, so taking a step back from the finished product you saw on the slide before, this is how we've approached the construction, and using materials that we've done over the last 2 to 3 years work on looking at different materials and the properties and the characteristics from the radar perspective and the IR perspective. And this is some of the things from that have fed into this. So as you can see here, we wanted to create, in this instance, an appearance of the target being empty. So you can see the material is facing sideways. So it's from the rear, it looks like there's nothing there, and that's what the radar sees. So that's the effect that you're creating there. And here you can see the small vertical sections build up a strength to the actual bed itself. So it simulates the bed and chassis as a stronger signature, and these are all just fabrics. So it makes quite a solid appearance. And we've got no support in backwards. I've just gone out of order here, so that's it. But there's the thing that makes it appear empty. So looking at the picture here at the base, obviously a lot of the signature in this instance, as Steve mentioned earlier, is at the axle and the wheels, but very little of the signature is higher up, apart from at the very rear end. So so we've obviously got to do some work here to make this more solid to the eyes of the radar, whilst also preserving a visual identity going underneath and between the wheels. So you can see here the rear section is made of a similar material to the PVC construction of our other targets. So this is similar in that way, so we know we can get the correct RCS and IR signature from the rear. Now, if we focus on the rear side, inside the 4 solid inflatable sections here, we have some rearward facing material that adds strength to the signature there. And then we have the pink sections, which are foam, and that creates an additional strength there where we believe we needed a bit extra at that point from what we were seeing. And here, this is just a side view showing dimensionals, the different things to do with it. And you can see here that this is where the radar can see through. So the foam sections are around here and here, and then obviously the radar can see underneath and out through to the other side. With the radar cross-section values, you can see the plots here that we're getting the signatures at the rear end, obviously, because that's the first thing the radar will scan. Then it will see the axles and identify with that, and you can see in the plot of the graph here the values we're getting. and that the readings we were taking at those points, and then we get a lower signature at the rear end. The slope here obviously reducing that signature quite a bit, which is part of the idea behind it. And this was compared to a real truck, and we've taken some measurements of a real truck as well. And in here, going back to the previous one, what we were seeing was 2.8 metre. On the real one, we're seeing 2.5 metre. We can vary that. This is how it came out for the target and the specification we were doing at the time. So that's it. All these measurements are based on the ISO standards that Steve mentioned earlier, and this one in particular is based on the draft part 11 that's coming up, which we're doing a lot of work on. So I think that's it. So yeah, that's a 2.5 metre back. That's the axle we're at. So that's it. I think it's over to you now, Steve, to go over this bit.
Yeah, the reason between those two differences is the truck we tested here has a different overhang to the truck trailer Vanguard in the USA. So that's the reason for the difference of the 2.5 and 2.8. Not many people actually know that those drive Vanguard trailers, the wheels are adjustable along the bed, and you can make that overhang change, which that we were asked to do the maximum, and so we have got the maximum overhang of 2.8 for a drive Vanguard trailer. So the next part was to then, once we've analysed the data and played around with our radar signatures and made sure we were representing the equivalence, was to then test it. And then we went to IIHS and we created the target, and then we did the tests that they were been doing. They had 3 cars that were there, a Kia, a Mazda and an Audi. The Audi was using LiDARs and cameras, the Kia and the Mazda were using radar and camera systems. And they previously performed the tests on a drive Vanguard trailer, a real trailer, and had the data already at hand of the time that the time to collision warning was activated. I think they used the OXDS and a AVAD system to activate and time that of the warning of the vehicle. So the next thing was for us to drive the same 3 cars at the target with the same tests and the same speeds to evaluate whether the results were the same for the real trailer or our truck trailer. And what's pleased to say, they were pretty much spot on. All 3 cars reacted exactly the same to the target as they did to the real trailer. The time to collision was pretty much exactly the same throughout the tests. And we went further onwards to actually test one of the cars that seemed to be braking or seemed to want to brake, and went through and started to get at 10 and did a A/B stop at 10 and carried on up to 70 kph and did a full A/B stop from at the trailer, and the car successfully did that. They tried a couple of the other cars to do the same. They actually also braked and didn't hit the trailer and stopped in time. So the conclusions were that we managed to replicate the real trailer very well, and that the 3 cars that they had all detected the real trailer, also detected our fake trailer with the same results. So, which made us obviously quite pleased, especially with straight out of the box as well. We had a few spares and a few tweaks if it didn't work, but it wasn't needed. It's primarily the radar signature was the issue, obviously because of the overhang and the right signatures. When we're trying to fake a signature out of inflatables and foam, it's always a challenge to get that. But I think with our experience now working with the ISO bits of things, we've got a good handle on that, and we managed to be very accurate with what we produce. So we hear the volume on the audio as well as some He's doing 70 kph at the target here, and he will do, you'll hear the fault, or see the fault collision activate, and it'll do an AEB stop at the target. So that's the fault collision warning, and it stopped. Right, I'll move the presentation back. So I'll go back to the presentation.
Okay.
There we are, back at the beginning. Yeah. So the next thing was to look at what happened when we impacted it. So we did a 10 and 20 kph impact, just to see how it reacted. The first one was a bit slow, actually, so I have to do it again at 20. We were just fine as the results of that. So I think you can see there's a slow motion of it hitting. It goes underneath, takes off the underride protection, goes up and rides up. The Audi we used, we had to override the sensors on it to permit that to happen. So to put tape over the cameras and over the LiDARs at the front to allow it to hit. We weren't too keen to go much faster at that point in time because it wasn't their Audi. But everything was fine. The Audi's quite high, so it lifted up in the back and causing the front to come up. And then it pushes the target further forward. Another video that actually hits the target, moves forward, slides along, detaches, and just disengages from the car. Of course, it's just inflatable, so it just lifts up. There's a foam bumper at the front there where the wheels are touching the front of the front air dam or the front lower fender. Is it a fender? What do you call a bumper of the Audi? Sorry, I was trying to speak American there. It was push it out of the way and it was fine. So we've had another tweak. We've actually enlarged that bumper element at the front to just give it a bit more cushioning where it strikes the front of the car. But there was no more issues on that. So that's the technical aspect of everything done. So what we have done since on the TRTR is we've had this element of customizability. There's several tests throughout the world. The Chinese CNCAP are looking at using a red truck, so we're available to customize the target. So now, as well as having the image on the back, we can have the image on the side. It's also printed on, so the motion data now, the motion data now is printed on there, and it also is the print of the sides of the dry vanguard trailer, the rivets, the aluminium foil elements of it, and the vertical uprights. We can add an image onto that to make that side, and we can change that colour the same as the rear end image, which is the next slide. So we can add any images we would like to that, try different colours. We can also add text to it, logistics, writing, some of the vehicles, especially here in Europe, have different writing on and different images. In fact, I've even seen one which had an image of a rhinoceros, a 3D, so sitting in the back of the truck eating straw whilst looking back at you. So it looked to be a hollow image on the back of the truck. Also, we can adjust the sides on the side of it as well, and we had logos to that as well, because the rear image can be one thing and you can have your own logo on the side of it, or anything you like on the side of it. Because as well as being a target, it's also a very big advertising billboard on the side of the test track. And so it's being 4 meters high and 6 meters long. So those can be customized, and we've also got options to shorten that overhang to make different shapes. As long as we have the concept, it's easier. So we've looked at the shorter, medium grade size truck with a different overhang, and also looking at extending it forward to make it a bigger, longer trailer for side and crossing. We're looking at now if we can match it off, which we think we can very easily. That's the next project, to put it onto our flex motion towing system, so it could be towed along. But I think the primary test that IIHS we're looking at that it was harder to detect a stationary vehicle than a moving vehicle. So that was the prime point behind their front crash prevention. It's 3 stationary objects: the motorbike, the car, and the trailer. People have asked if it can be moved, if it's moving. So it will be a total, probably not much more than about 20 kph, which is 10 or 15 miles per hour. And basically because of its size and the wind load on it, we have reduced obviously that wind load by having the shape at the front, which would be the direction it's travelling, to try the wind load to go over it. And so it might change shape if we needed to move slightly, but it's have to maintain that integrity at the rear end to get the full size of the drive van guard trailer. So we're now going to take some questions.
Yeah, so we actually have a few in the Q&A section. So one of the first ones is actually whether it could be a dynamic target through GST and all the flex tow system. So you've had answered that, so that's something we could do, but it will depend on the situation.
Yeah,
which actually,
so the chances of going on the GST would be complex because of the dimensions of the GST, and also we need a source to power it. But it's something we could look into, but it's having that source to keep the air inflated inside it, which we can do with the flex, because we can have the hose going along the flex and being towed by the generator and power and the inflator in the actual tow vehicle, which would give you a straight line capability of driving along.
a second question that's come up was whether what was the maximum ambient wind it was tested in, or what we think we can be set up.
We had it around about 12 or 15 miles per hour winds. It was starting to move, but we needed some more sandbags, and there's never more available. So that is an issue with it, but it's always going to be an issue with a tire so large. It's not going to be suitable on windy days. Up until those gusts, it was fine. It sat there fine. We have got straps available, and you can tighten down the base. There is availability to put more sandbags on the base to give it a greater load. And there could be weights to the side of it, depending on the vehicle visuals of those weights on the side of it. So there is those aspects of it that becomes an issue. They'll be tied down to the track. It all depends on how the vehicle sense those objects to the side of it, whether they're seeing it. So it depends on the development aspect of that.
Okay. Another question was the ISO certification. Is it 19206-11 certified? Is that what you said?
So the Part 11 certification is still in draft format, and we're helping to develop that. So watch this space, because that is being developed now, and we will be obviously our target will be one of the key things that feeds into it. So better say it's a draft document at the moment, but it will certify to that.
Okay. Another one is whether the IIHS is going to update their FCP 2.0 tests for dry van trailers impacting.
Yeah, well, we're in discussions with IIHS now about that, and about them. They finished the last round of testing, and I think they published it a few weeks ago, the last batch of cars, and they didn't want to change anything in that batch of cars. And now they're discussing whether it'll be a comparative test for the next batch of cars if you're using a target for the trailer. But I think the test drivers were keen because they had to sign a waiver. They wouldn't have any problems if they crashed into a green trailer. So I think they were quite keen to take on this target. And now that those batches of cars and that test phase is finished, they're in discussions to talk about.
Okay. Another one is the weight and volume when stored / collapsed.
The inflatable itself is quite small. It goes into a bag about 4 feet square and 4 feet cube. It packs up into that. The foam in the centre is one of the biggest parts of it, and then the base fits into a crate about 4 feet by 2 feet, about 2 feet high. It's a wooden pallet. All the base goes into the accessories and the tools and the bits and pieces. The foam blocks sit on top of that, But generally the whole thing fits on a pallet and a crate. I think we get to ship it on a standard skid, as you call it in the USA. We can get the foam and the inflatable on it, and then the box goes separate with the base in it.
And the blower as well.
And the blower as well, yeah.
And inflation and deflation time.
Well, the inflation time isn't very long at all. Basically, the method you use to inflate it is you drag it out of the bag, attach the inflation tube and part inflate it, and there's a zip on the rear end, and that zip you can control the pressure. You keep it slightly less pressurized while you add it to the base, and you slide it onto the base using the C section and the fabric into the C section, and then you can fully inflate it. So it takes about 35-40 minutes to get it out of the box and have it assembled. Because to deflate it, if you go to lunch or you stop and test it for a few weeks, a few hours, you just switch the power off and it deflates, switch the power back on, and it takes a minute and a half to come back up to full size again. And then similarly, when you disassemble it, it's a case of just reducing the pressure, taking the images off the wheels, taking the foam out, sliding the base off the key rail, and then letting the pressure down, folding it up back into the bag, and disassemble the base. The base is in 14 pieces. It's put together with like dog bones, so it's glued together. It not interlocks into itself, and so it all packs up into, I think the biggest part of each base is 2.5 feet by 2 feet wide, or 3 feet by 2 feet wide.
1 meter by half meter.
Yeah.
There's the base pieces.
Yeah.
I think the installation of the base takes longer than the actual inflation and installation of the inflatable as well.
Yeah.
Okay.
Yeah, we have the cost of it is published now, and so Brent, who's on here, he's our representative in the USA. He's available. He can give quotes. We've sold 3 of them. There's a 4 or 5 week lead time on these. Then the cost in dollars. Brent will know the cost in dollars if he's there. If he's on the line, keeps it being there. You see that?
I think he's still in.
Can I unmute?
Brent's had trouble. He's the only one who's had trouble with the presentation today.
There we go. He's been unmuted, so we can.
So we can unmute Brent.
He can speak now.
Hi, can you hear me now?
Yeah, we can hear you, Brent.
Yep. So yeah, anything that you need from me. I don't know if you've probably gotten emails from me, or we've talked, or they've been passed to you, the invitations for that. If you want to talk further about pricing and details about delivery and whatnot, I'm happy to have that conversation with you at your convenience. So, or via email.
Yeah, at this point, there are no more written questions. So if anybody wants to discuss things more openly, we can either do raise hands or we can just unmute people. But this is coming to general chit chat. So I think if we can go just to the last slide, there's some contact information. If you would like to get in more detail with either Paul or Steve for some more information about the product itself, and also for Driver Assist Tech, who's helped with today's presentation.
So maybe if there are questions, you can just raise your hand, or unmute you, and we can do it face to face or face to voice, as opposed to typing. It's funny, actually, it's 1641 on my here in the UK, and that's exactly the same as when we finished the last one this morning. We did, and we tried to slow this one down and make it longer, because we did it too fast. So we still ended up with 1641, because exactly the same time I looked this morning. So if there's no questions, thank you for attending, and thank you for coming on to listen to our little talk on how we designed and engineered the TRTR.
Yeah, thank you very much.
Yeah, if you've got any questions on anything target related when it comes to radar signatures and various things, more welcome to contact Paul, who's our ISO expert and the expert on the radars and the evaluation and the design element and how we, because that's the tricky part, is trying to get a radar signature correct, especially when you're using fabrics and foams and non-metallic objects. Make sure they're in the right place as well, and the right amount of signature in the right place.
Yeah.
And not having too much signature in the wrong place as well. But, yes. You answered that one.
Yeah, so the recording and some of the information about the product will be available at a later date. We'll be messaging those out once they're ready.
Well, thank you very much for your time.
Thank you very much.
Thank you.
Thank you all. Bye-bye.
Thank you.
Thank
Bye.
you.